Jiangsu Province is one of China's economic powerhouses, ranking among the top in industrial output, agricultural production, and living standards. Covering 39,600 square miles, Jiangsu has long been a key part of China's history, with Nanjing, its administrative center, serving as the national capital multiple times. As of 2020, Jiangsu had a population of around 85 million, and for some of them, a massive new reservoir system has been built. This project is truly impressive. The upper reservoir, perched on a mountaintop, is enclosed by towering 600-foot-high walls and holds 4.5 billion gallons of water. Below it, another large reservoir helps ensure water supply stability. But why did China build these reservoirs, and how will they benefit millions? Jiangsu's economic strength is undeniable. In 2022, its GDP reached 12.29 trillion yuan, or $1.83 trillion, making it the second largest provincial economy in China, just behind Guangdong. To put this into perspective, Jiangsu's economy surpasses that of Australia and South Korea. If Jiangsu were an independent country, it would rank among the top 15 economies in the world, highlighting its immense economic influence. It's also China's wealthiest province in terms of GDP per capita. In 2022, its nominal GDP per capita crossed $21,000, making it one of the most affluent regions in China. However, this wealth is not evenly distributed. Southern Jiangsu, home to cities like Nanjing, Suzhou, and Wuxi, is significantly more developed and wealthier than the northern part of the province. These cities are major industrial and technological hubs, attracting domestic and international investment. Suzhou, for example, has a strong presence in advanced manufacturing and electronics, while Wuxi is a key center for biotechnology and software development. With its high GDP, robust industrial base, and technological advancements, Jiangsu plays a crucial role in China's overall economic growth, contributing significantly to national exports, research, and innovation. With great wealth comes booming industry and agriculture. Jiangsu has an advanced irrigation system that supports rice, wheat, and corn production. For export, it cultivates cotton, soybeans, peanuts, sesame, and tea, along with silk, which remains a key industry, particularly around Lake Tai. Jiangsu's industrial sector is equally impressive. It has coal, oil, and natural gas deposits, but its most valuable resources are non-metal minerals like halite, sulfur, phosphorus, and marble. These resources fuel industries that require vast amounts of energy. A region as developed as Jiangsu needs an enormous amount of electricity. A significant portion comes from other provinces, including via an ultra-high voltage DC transmission line from the Baihetan Power Station, a massive hydroelectric facility with an installed capacity of 16,000 megawatts. It generates approximately 60.2 billion kilowatt-hours of electricity annually. Jiangsu has also invested in renewable energy, including wind farms like the Rudong Wind Farm, which produces around 375 million kilowatt-hours per year, reducing CO2 emissions by 247,000 tons. However, despite these efforts, the province still heavily relies on coal and oil. This dependence is problematic due to its flat terrain, low elevation, and high population density. Jiangsu is particularly vulnerable to climate change and rising sea levels. From 1961 to 2007, the province's average temperature rose by 0.38 degrees Fahrenheit per decade, and rainfall has increased, intensifying extreme weather events. These climate shifts threaten agriculture, water resources, transportation, and coastal areas, making energy security a pressing concern. To address these challenges, China constructed the Jurong Pumped Storage Power Station. Approved by China's National Development and Reform Commission in 2016, construction began in 2018, culminating in a groundbreaking energy facility. The station consists of two reservoirs, one at the mountaintop and another on Lunnon Lake. The upper reservoir's main dam stretches 2,650 feet and holds over 4.5 billion gallons of water. The lower reservoir is slightly larger, with a capacity of 5.2 billion gallons. This is a pumped storage hydropower station, PSH, meaning it operates by cycling water between the reservoirs. During low electricity demand, excess power pumps water to the upper reservoir, storing energy. When demand peaks, the water is released, driving turbines to generate electricity. Jurong's design ensures substantial energy output. The system includes 6 single-stage vertical pump turbine units, each rated at 225 megawatts, producing a total capacity of 1,350 megawatts. Additional infrastructure includes an underground power station, a water supply system, and a surface switching station. The project's cost, 9.6 billion yuan, $1.3 billion. But the benefits outweigh the price. By March 2025, 4 of the 6 units had begun operation, with the remaining 2 set to launch by the end of the year. Once fully operational, the station will generate 1.35 billion kilowatt-hours annually, enough to power about 360,000 households. Moreover, it will cut CO2 emissions by 357,000 tons and reduce coal consumption by 134,000 tons per year. To distribute this energy efficiently, 13 miles of power lines and 53 iron towers were built, connecting Jurong to the national grid. This additional infrastructure enhances energy security and contributes to the Yangtze River Delta's shift toward low-carbon energy. However, constructing this facility was far from easy. Half of the power lines had to be built in mountainous terrain, requiring innovative methods to minimize environmental impact. Advanced construction equipment, such as visual tension devices and digital cable processing tools, ensured minimal damage to local vegetation. Builders also faced geological challenges, including karst sinkholes and unstable diorite rock formations. To overcome these, engineers used advanced detection technologies like borehole TV imaging and seismic CT scanning, identifying and reinforcing weak areas with pre-stressed anchor cables and rods. Another impressive aspect of the project was its efficient resource use. Nearly all materials for the upper reservoir were sourced from a nearby excavation site, achieving a remarkable 99% utilization rate, cutting costs and reducing environmental disruption. Jurong's location, 40 miles from Nanjing and 22 miles from Zhenjiang, ensures that its clean energy benefits densely populated, high-demand areas. Nanjing alone has over 9 million residents, many of whom rely on agriculture, forestry, and fishing, sectors that demand significant water and electricity. The Yangtze River provides water, but irrigation and processing infrastructure require a steady energy supply. In 2019, these industries generated $6.5 billion, reinforcing the importance of reliable power. This PSH model isn't new to China. The Fengning Pumped Storage Power Station in Hebei, which began operations in 2019, is the largest in the world, with a capacity of 3.6 gigawatts. Originally built to support the 2022 Beijing Winter Olympics, Fengning now plays a crucial role in stabilizing northern China's energy grid. Located near Beijing, a city of 22 million people, Fengning helps offset reliance on fossil fuels. Coal still dominates Beijing's energy mix, accounting for 40% of electricity production. Although coal consumption has been gradually reduced, Hebei Province, surrounding Beijing, burned over 300 million tons in 2011, more than Germany's entire coal usage. While China is transitioning to renewables, fossil fuels remain a significant part of the energy landscape. Projects like Fengning and Jurong provide a path forward, balancing clean energy storage with peak demand management. Jiangsu's economic success hinges on stable and sustainable energy. The Jurong Pumped Storage Power Station represents a critical step toward reducing reliance on fossil fuels while ensuring energy security. By integrating clean storage solutions, China continues to innovate in tackling climate challenges and powering its economic hubs. This ambitious engineering feat may soon serve as a model for future energy storage projects worldwide, proving that large-scale solutions can address both economic and environmental challenges.